Hey everybody, Lars here. It is Friday, June 12th. I am shooting this, I always want to say live, but it's not live, but it is contemporary. It's summer of 2020. Um, we are going to take a look at a couple of things and then we're going to do some announcements. Basically, what I want to do is go over Project Euler, let you know what it's all about, and then give the sixth problem a go and explain what all that is about. I don't want this to be a long one. I want it to be quick because I know I'm shooting you videos, and I don't want you to think it's a chore. I don't want them to be super long. The reviews for the slides, I don't mind if that goes a little long because you're smart enough to compartmentalize and watch what you need to watch in different sections. This, though, I'm going to get in and I'm going to get out. We'll quick do the Project Euler stuff, and then we'll do some announcements at the end. You guys are doing great so far, so we got no worries. We'll talk just a little bit, and I think I gave the hint at the end of the last video I did for this summer. But we'll talk a little bit about the quizzes because basically I just want to get the point across again that if you see code in quizzes, run it. I don't mind. Run the code and get the answer that way. All right? All right. A long time ago in a galaxy far, far away, there were no Python courses at Rutgers University. I was not the first. There was one down in Camden. And what happens is the Masters of Business Science program used to send their students down to Camden. And then one semester, the professor down there that usually taught Python went on sabbatical. So Dr. Silver over at the MBS Googled Python space Rutgers, and my name popped up because I was teaching Python for an enrichment school called the Heroes Academy over in New Brunswick. And it was around that time, 2014, 2015, that I developed my course. So before 2015, there wasn't any Python in New Brunswick. And back in 2010, 2011, I don't think there was any Python courses university-wide. And what would happen is I work for the computer science department. I created a collaborative lab called the Cave. It's kind of the de facto headquarters for the undergraduate CS kids. And they would come into the Cave and they would say, I want to learn Python. What class should I take? And we would tell them, hey, there's not really a class you can take, but what you can do is this. And we would send the students off to a website called Learn Python the Hard Way. Now, you're going to get familiar with that because it's going to be one of the 3 resources that you're going to take a look at to do your midterm. I'll get to this in announcements, but you're going to find out about your midterm over the weekend. And it's a paper. It's not an exam. Not a fan of exams. So we told people to go do Learn Python the Hard Way, which is obviously a joke. It's a simple way to do it. And when they were done, they should go get practice. And the way to practice was to go do the first 50 problems at Project Euler. And what you learn, I actually have the website up already, is what you learn is that Project Euler is a site that has around, up to now, I think it may be 700 number theory problems. And what we're going to see later when we get into it and we take a look is I created an account for this particular class, and we're going to log in as this class and put in some answers. But as you can see, if I go to the very last one, there are now 709 problems to solve. Now, these mostly are number theory problems, and they lend themselves to being solved with computer programming. Okay? So you can use Python, you can use Java, you can use C++. We're going to do it in Python. And I would tell the students to go do the first 50 problems. And if you do the first 50 problems, and you'll see, because we'll take a quick look at the stats later that are on the website, you're like within the top 5% of people who use Project Euler, and that's pretty good, and it covers a lot of different things. So we would tell people after that, you pretty much know Python pretty well. Whatever project you wanted to use it for, you're now ready to go. Give it a go. Okay? So for the longest time, that's what we told students. Then the Camden course happened. A couple years down the road, my course happened, and I started teaching Python for the graduate students in the MBS, and time has gone on. But I always introduce people to Project Euler because a lot of times people will say, oh, I wish I had more practice. I wish I had more exercises. I wish I had that. Can't say that anymore because we're about to take a look at 700 different number theory problems that you can solve with computer programming. Now, one last thing before we get to it is what we're doing today is not really something we should be doing. And the reason is that you're not supposed to advertise or show Project Euler solutions because you're supposed to leave the problem so that people can go to them fresh and they can solve them themselves, right? That said, the dirty little secret is about the first 100 Euler problems are all online. If you went to Stack Overflow, and believe me, all us computer science professors know about Stack Overflow. We know about GitHub. We know about Reddit. We know about all the places to go get your homework done. Unfortunately, we have to know about that side of things. So if you looked on Stack Overflow, you would see the solutions for like the first 100 Euler problems in Java, C++, Python, a whole bunch of different languages. So we know that. What I tell students is give it a go because you're not going to learn unless you give it a go. Don't just try to Google the answer right away. If after what you consider a decent amount of brain twisting, you still are unsure of something, then okay, fine, go to Stack Overflow and look and do that. My thing here is that we're going to look at number 6, the sum square difference. Number 6 has been solved by a ton of people. Number 6 is one of the easier ones. Okay? So it's not so bad if we just go over the solution to that. Also, a reason that I come here and a reason that I do this video now is you finally got enough tools in your tool belt that you can start solving real problems. Because now you have variables, you have decisions, you now understand a little bit about lists and sequences. You have iteration, which is probably the most important thing. You know how to do a loop now. So I figure we'll go out and we'll solve a real honest-to-goodness problem here on the web for Project Euler. So what we're going to do today is we're going to tackle number 6. And when I click on 6, it says sum square difference. You see, the sum of the squares of the first 10 natural numbers is 1 squared, 2 squared. It equals 385. But then the square of the sum of the first 10 natural numbers is add them all up, square them at the end of the show, and you get 3025. Take the difference, and you get 2640, and that's the answer. Okay, the difference of these two variables. But then what Project Euler says is now find the difference between the sum of the squares of the first 100 natural numbers and the square of their sum. So whereas 1 to 10, yeah, maybe you can do it on paper. Maybe it's easy to just noodle it. When you're doing it with the first 100, if you have some facility with a calculator, it wouldn't be so bad. But if you want to do it for the first 100, now all of a sudden you can't pen and paper things. So now it's actually convenient if we have a computer program to do things. So I'm going to show you what I do with Project Euler problems. What I usually do is I highlight them, and I'll copy. And then what I will do is I will fire up my Python. Where are you? Here we go. And then I'm going to create a file, new file, that we're going to call E6. And I'll call it Euler 6. And I'm going to say 1, 2, 3. 3 apostrophes so I can start a comment, and then I'm just going to paste it in there. Now it doesn't look very good right now because it's not all on the one screen. Let's do that. Okay. These are kind of messed up because that should be 1 squared, 2 squared, 10 squared. Okay, but you understand what's coming in. So now I actually have the definition of the problem up there in my comments. so I don't have to worry about things. Let me real quick get this part of it out of the way. I'll just call it E6, and I'll put it on my desktop. Okay, so now we're ready to solve Euler 6. Euler 6 is interesting in that it's not really one problem. It's 3 problems. The first thing I want to do is I want to find the sum of the squares. Then the second thing I want to do is find the square of the sum. Then finally, the third thing I want to do is find their difference. Okay? So technically, that's 3 different problems. So in my programmer brain, I say, okay, let's tackle them all one at a time. All right? So the first thing I'm going to do is I'm going to tackle the sum of the squares. So the first thing I'm going to do, and you'll see why in a minute, is I'm going to say SOSQ. I'm going to make it equal to 0. I'm going to set up a variable where I'm going to keep this total. I'll show you why I do it right away in a second. Then I'm going to start a loop. I'm going to say for I in range 1, because I want to start with 1, and I want to go to 11. Why? And I say it in the slides, and you're going to hear me say it a lot. 11 is the first thing I don't want. The end of an interval in Python is exclusive, not inclusive. Okay? So that is going to provide me with a list from the numbers of 1 to 10. And that's what I want, because that's what it says up in the instructions. Then what I'm going to do is I'm going to say the sum of squares equals the sum of square, because I want to maintain my old values, plus I, which is that variable right there, raised to the power of 2. So every time through the loop, I'm going to square the number and add it to the variable. Square the number, add it to the variable. Square the number, add it to the variable. Just to check in the middle of things, let's do a print statement and see what it gives us. It would behoove me to do the right variable. So that's what I want, right? Sum of squares, yes. So I run it, and I get 385. That makes me feel good, because when I come up here to my worked example, boom, I see that it's 385. So I'm in good shape. I already have 1/3 of this thing licked. Now, and I'll tell you about this. Yeah, you know what? I'm going to tell you about this now. If I did not have this line here, this program would explode. Boom. And it would say that the variable SOSQ is not defined. Okay? I can't see it anywhere. And the reason it says that is because I refer to it here on the right side of the equation. Now you can see over here on the left side, that would be fine because I'd be assigning the variable, I'd be setting the variable up. But here, I refer to it before it really exists yet because of the particular nature of what we'll later come to call an accumulator. Okay? No, not later. We're doing it right now. So that's an accumulator. So what I want to do is very simply just define it. So I set up the variable and I make it equal to 0, and you'll see this a lot in programming. You define the variables and you get them ready to go so something like this doesn't happen. Now that I've created the variable and it's ready to use, then boom, I'm okay. Well, nothing happens because I got rid of my print statement. So what do I do here? I'm going to create a new variable. I'm going to call it square of sum. Only this one's a little bit different. I'm going to say I for range 1 to 11. And, oof, how did that happen? Goodness gracious. And for I'm not doing things properly, in range, whatever. I'm going to do square sum equal to square sum plus I, because I want to add everything up first and then square it. So what do I want to do here? I don't really want to be in the loop anymore. I want to go through the loop and add up all of the numbers, okay? And then outside of the loop, I want to make square of sum equal to square of sum squared. And here we'll print square of sum to see what we have. And we're good. 3025 as you come up here to our worked example. You have 3025. So we are in pretty good shape. Okay? So I'm going to get rid of this print line. We've got one thing left to do, and I'm going to just do it in the print line. I'm going to print the difference, or just diff is fine. The diff is string literal, and then I'm going to say square of sum minus sum of square. Okay? Because at the end of the day, that's what the problem is asking for. And if the Python gods are with us, we will get 2640 as the answer. And we do, 2640. Okay? So now, we're not done yet, because what we've done is created a program that mimics the solution that we were given, the worked example that we got in the example of the problem. But that's not what Project Euler is asking us for. Project Euler is asking us for the difference between the sum of the squares of the first 100 natural numbers and the sum of the square. So, now that we're Python programmers, that's easy, right? All we have to do is this. Boom. Take that 11, make it 101 in both spots, and rerun the program. And that quickly, we've come up with this number, 251,641,50. So, before we come back to this program and make a couple of changes, because my programmer OCD gets crazy when I see that. You'll know why in a minute. I don't know. Is that correct? I don't know. I'm hoping for good things. So what I'm going to do is I'm going to copy it, and then I'm going to go back to Project Euler. And what I'm going to do is I'm going to sign in. And I'm not going to sign in as myself. I'm going to sign in as PMDS dash capital S lowercase u for summer 20. That is the account that I set up for this class. The password is Python class. Okay, all lowercase, Python class. You put in the confirmation code so Euler knows you're not a bot. I'm not a bot. Okay, and then you sign in. And as you can see, I'm sure I'm zooming in on it, we're logged in as the class, and now you see a list of all of the different problems. That said, there's a difference this time. I click on this, now there's a place to put the answer. Okay? So if you want to check the answer that you've done, now, because I highlighted it before in my Python, I'm going to paste it in there, and now I can check. And I can see if I have the correct answer. Okay? I think we're going to have good things. I'm going to hit check, and then a really cool thing's going to happen. Boom, check. Oh, it's taking a while. That green check mark is one of the great buzzes that an early programmer is going to have. When you see that green check mark, it means you have correctly answered the problem. Indeed, what we did was correct, and that's the solution to Euler 6. And what you're going to see is now you can click on progress, and you can see we've got problem 6 solved. Problem 6 has been solved by roughly 500,000 people, and the difficult rating is only 5%. It's not one of the harder ones. Okay? But as you can see, here are all the problems, so you can track your progress. You can even come over here to statistics and look at the problems and see how many people have solved them. And if you come down the line, it's about the same. It's very close. Oh, look at that. It's right there. Okay, when we used to send people here, we said do the top 50 because it'll put you in the top 5%. And that is still the case. Odd. That fluctuates. Okay? So you can do stats and see who's doing the problems, who's doing a lot of problems. You can see most people will come do 3 or 4 problems and then they'll give up and they'll never come back here again. If you stick with this and you do anywhere between 20, 25 problems, it's unique and it puts you up there really quick. You'll see once you do 20 problems, you're in the top 15% of people who are answering questions. And you can see if you do 200 problems, then all of a sudden you're in outer space. If you do all of them, and there are very few people, look at that. There are a few people who do all of them. And you can look up their names on scoreboard tables and stuff like that. But that's not what we're worried about right now. Right now we're worried about old number 6. And now that we've answered it, okay, anytime we go back there, it shows us the answer. Because we've already gone through it. Okay? And what is this? I'm assuming. Okay, it's just a forum on problem 6. Interesting. All right, so go check out, read the about for Project Euler. Take a look at some of the programs. Some of them are hairy. I'm not going to lie to you, but some of them aren't that bad. Okay? Then you can learn about statistics. You can learn about different levels and different awards. You can go to awards and you can see there's one for pi, where if you do all the numbers in pi, and you get a prize when you do the first 25 or the first 10 or the first this. They make it fun. It's a good job. It's really a good job. You can do things with friends. Now, if you want, you're more than welcome to do an Euler problem and log in as this class and just do it. But if you also want, accounts are free. So you can go get your own account and start solving problems and building up your own database of Euler problems. You can do different skins. I know if I log in as myself, I have a brown background and the text is white and different things like that. So Project Euler is neat. Project Euler is a good thing for programmers to use when they're learning, and not just now in case you're learning your first computer language, but a year from now you may find out that, oh, you know what, the problem I have to solve is probably better solved using Java, or it's better solved using C. I want to be closer to the gear. If you find yourself having to teach yourself another language, which won't be that hard going forward, you can then use these problems again and say, okay, now I did it once with Python when I took that course that last summer, but now I can go back and solve these problems using C or using some other language. Okay? So Project Euler is always going to be there for you. All right? That's always cool. Now, let's go back here, and I'm going to make a couple of changes. My programmer brain sees that 101 that we had to change in 2 different spots, and I don't like that. I want to change it in just one spot. So I'm going to create a variable for the end of my interval, and I'm just going to call it limit. And then up here, at the very beginning of the program, I'm going to define limit. And I'm going to say limit equals 101. Okay? So, if I rerun things now, I'm still good. I get the same answer. But that's not really what a Python programmer would do. One of the big things about Python is that it should be readable. Okay? It should not. One person once said of Python that Python is like your pseudocode just starts working, where you write down simple instructions about how the logic should go, and then boom, it just starts working. So my limit, what I really want to do when I say limit, is 100, because I'm doing the numbers from 1 to 100, so I want to say 100. But then I have a problem. What's my problem? In my range, if I go 1 to 100, well, then 100 will be the first thing I don't want, and I'll only do the numbers between 1 to 99. I rerun, and now I get a funky answer. Were I to put that in Project Euler, it would tell me to go pound salt. It would say, get out of here, because it's not correct. Okay? What happens is, and you'll see this a lot in Python, people just tack the 1 on the end of the variable. Okay? And you'll see that'll happen a lot if people want to use a variable to keep that number and then just make their interval work by tacking a 1 on the end of it. So now when we rerun, boom, we're back. And now if I want to go back to the original worked example, I'm back because I made it 10. And now if I want to go up to 100 and answer their question, I can go back up to 100. Okay? The reason I do this is to show you the little trick, to show you that you can use variables in your intervals when you use range and you do other things like slicing and things like that with the strings. You can use variables, and if you've got to change a variable in more than one place, it's always a good idea to just set up a variable and go change it in one place because it's more efficient. Later, when we become more sophisticated Python programmers, you're going to see a lot of times you'll set up variables like this in a library, and your program is going to read them from your library. So then you just have to go into one spot, because later on our programs are going to get bigger, so you're not really going to have everything on one screen. All right. So that's it. That is the solution to Euler 6. Now, what's interesting is after Unit 3, when you learn a little bit about functions, we're going to return to this problem. And we're going to solve it again. Only now we're going to solve it and we're going to use the knowledge that we have about functions. And then we're going to learn about a little something called list comprehensions. And then it may sound odd at first, but that entire problem, we're going to solve it in one line. All right, I'll show you how to do that. All right, it's a little bit of a parlor trick. I'm not going to expect you to do it, but I'll show you how to do it. All right, so announcements. Basically, everybody is doing great. Okay, we're rolling. Summer goes quick, doesn't it? Isn't it crazy? I would think it would be slower because every day is the same. Everything is still shut down pretty much in New Jersey. I can't get to the damn barber so I could get a buzz cut and get rid of all this crazy hair. I'm going to start to look like an old hippie. But things are going fast. It's already the middle of June, for goodness sakes. We're already nearing the end of Unit 2. There's only 6 units in this course. Keep this in mind, and I'll do an announcement to this later so it goes into your mailboxes. But the discussion post is due tonight, Friday night at midnight, okay? And then there's only 3 days left for the unit after that. The quiz is going to open up at 8 o'clock on Sunday. It'll go from 8 to midnight on Sunday, all day Monday, and then you get 2 more hours after that for those night owls out there. So it'll go all the way to 2 a.m. on Tuesday, okay? You get 30 hours to do the quiz, which isn't bad. You've already seen one quiz, so you know I wasn't lying to you. They're not great shakes. They're not difficult. Half hour, 45 minutes tops, okay? If you're going through the unit, if you've done what you had to do, and then you did the assignments, that little piece of coding you have to do at the end is not backbreaking. It should be fine, okay? My best piece of advice to everybody is keep doing what you're doing because everybody's doing well and things are good so far, all right? Again, I just want to reiterate, if you, in a quiz, get a question like, what is this in code? Like in quiz 1, I asked you the value of my bool. Just put it here in Python, okay? You can put it here in the interactive window, and you can solve the problem. Let's do that. You know that? Let's go ahead and do that. So, quizzes. How easy is this going to be? Quiz 1. All right. Preview. Edit. I'll go to edit. I'll cheat because I'm the professor. Questions. Right here. My bool equal to all of this hot mess. Just take it, highlight it, go to your Python, paste it in. Now, one thing that you may have learned is those things are funky. Okay? Basically, the secret to this is that strings are not the equivalent of their integers. Okay? Then my bool is done. Type it in and look at the value. Boom, true, done, answer. What did that take us, 10 seconds? Okay? Now, you can do the mental gymnastics and you can sit there and say, okay, that's true, and the or is there, so the fact that that is true means it's okay that that's false, and then I'm adding true and true, which is true, and blah. You can do that. Or you can just take it and run it. You can throw it into Python and run it in Python. I have absolutely no problem with people doing that. Okay? So know that. We're learning Python in order to use it. What else has come up? Also, and it didn't happen that much, so it's not that big a deal, but remember, you've got to hand in a Python program. You've got to hand in this guy right here, the .py. All right? I didn't mean to do that. Some people are sending screenshots of interactive windows, or they'll grab all of this and they'll cut and paste. This is the interactive window. Think of this as like a console, all right, to get you set up. It's the program that we need, all right? Because that's what you're going to be doing in the future. You're going to be writing programs. Or Python, I don't know why they bothered to do this, but it's a pain in the butt. But they call them modules, Okay? Later, you're going to find it does kind of make sense because different modules plug into different places and different pieces of code build a system. And at the end of the day, that's what we're going to do. But now that we're learning, we're really only learning with the one module or the one program. Okay? Also, your midterm, which is just a 5-page paper, which is just a 2.5-page paper, and then the magic of double spacing makes it a 5-page paper. So it's not a backbreaker. You're going to have to go to 3 different online Python sites. Code Academy, Learn Python the Hard Way, and we're going to go to YouTube and we're going to watch one of the Harvard videos, the class that Dave Milan does. All right? And then I'm going to ask you to do a compare and contrast of the 3 different resources and then compare them to traditional instruction. Not a heavy lift. I'm going to provide you with the instructions for that this weekend because that will give you an entire month to work on it. Today is the 12th. It is due July 12th. So you have an entire month to work on that midterm. Okay? At the end of the day, it's fun. At the end of the day, it's extra practice, and we'll get into it when I release that. So I will release that. That said, don't let it distract you. Worry about Unit 2 right now. Worry about your assignments because the assignments are due, what, Monday night? Monday at midnight. You still have some time. Okay? Discussion post is due tonight. Low-hanging fruit. Watch that Slavin video, which I've always thought was cool. It's starting to get a little bit dated, but it still kind of works. So, but I've always thought that that algorithms video was really cool. Do that post because it's due tonight at midnight. Now, if you miss it and you're watching this on Saturday and you're going and doing that V8 and going, oh, I missed it, I feel terrible. Still do it because you only lose 1 point coming in late. You can still get 4 points for it. If you try to post it after Monday, though, it's going to be a 0 because you can't do a discussion post after the unit ends. Okay? Everyone, I think, kind of gets the workflow now, kind of gets the gist. Oh, okay. First you read the slides, then you look at the review videos, then you kind of do some examples and play around a little bit. Oh, now I've got the assignments. Now you can take what you've learned and tackle those assignments because then you're the practitioner. Then once you're done with the assignments, you kind of look at everything, rewatch the videos a little bit, maybe play with some other stuff, boom, and then the quiz happens. Okay? And the quiz, you guys know, it's not a quiz. It's a 1-day open book project. And because you've been through it all and because you've done the assignments, you know now. You know where to go to find the resources, where in the slides to find answers. Maybe there was an example in the code to do this. And then you can do the quiz. All right? I know you're getting it because everyone's doing well. So things are good. All right? Have a good weekend. Get some Python done. I will likely open Unit 3 on Tuesday. I don't want to get too ahead of myself. And Unit 3 is a long one. Okay? Unit 3, I think, is going to go up until 4th of July. Because it's a long one, and I give people time for it because the assignments are comprehensive. They'll go back and they'll touch on everything we've learned up to this point. Because like I always say, we spend the first half of the course learning Python, and then the second half of the course using Python. So you're a little bit more than halfway there already. Very soon. All right? All right, then I'm going to get out of here. You be good. And I will likely get the next new video in the middle of Unit 3, where I do a little example of a homework assignment, and then I do some other things in Unit 3. So there's a very good chance you're going to get a contemporary summer 2020 video out of me, possibly 2, because I'm going to want to explain what's going on with the 2 assignments in Unit 2, because they're actually kind of fun and they're actually meaningful for different reasons. And I know I sound cryptic, but you'll know what I'm talking about when we talk about it. All right, I'm getting out of here. Have a great weekend. Keep doing what you're doing, and I'll talk to you later. All right? Bye.